A ball is thrown straight up into the air. The relationship between the height of the ball and the time since it was thrown can be modeled by the function f of x, where f of x represents the height of the ball after x seconds, which function reveals the maximum height the ball reaches. All right, so the first function they give us, this one's in standard form, and you can find the vertex by doing x equals negative b over 2a, and then substitute that in to find your y value. All right, the second, all the answers are in vertex form. So vertex form, remember, is y equals a times x minus h squared plus k, where h and k are your vertex. All right, so let's go ahead and look at the original function. So we know we can find our vertex by doing negative b. A is negative 16, B is 96, and 6 is C. Remember, the A, B, and C come from your numbers here, your coefficients, and your constant values. So negative B is negative 96 over 2 times A. A is negative 16. All right, so x equals negative 96. 2 times negative 16 is negative 32. Negative 96 divided by negative 32 is positive 3. So that's going to be a positive 3. Then we're going to find the y value. So we're going to take the equation and substitute 3 in place of x. All right, so we're going to do negative 16 times 3 squared plus 96 times 3 plus 6. Make sure you've got everything typed in correctly. Hit enter, and it gives you 150. So when you have standard form, a is negative 16. When you convert it to vertex form, a does not change. So we can say, with what we just found, a times x minus h, our x value of our vertex is h, so minus 3 squared plus 150. So that's going to be our equation. So D is going to be the correct answer. Now, what if you don't remember how to find the vertex this way? Well, another way you could do it is to graph the standard form and then graph these and see which equation is the same graph as the one in standard form. Desmos is a great way to go ahead and look at that. So I have already graphed these just to save a little time. So the line in red, you can see here, that is the original equation in standard form. All right, so that's the equation we had. And then we needed to write it in vertex form. And then you can see here the blue one, the vertex only goes up to 3, 6, which is what's given here, nowhere close to the line, the red line. And then the green one, here's the green one, has a vertex of 3, 15. Again, nowhere close to the red one. And then here's the purple one. It goes up a little higher, 343 and 144. All right, so that's the vertex there, but still not quite where the red one is. And then the one in black goes up to 3 and 150, which is the exact same as the original one in standard form. So you can see that these two equations are the same. So that's another way that if you can just remember, if you don't know how to do vertex form, remember you can just type those in and see which one looks like the one in standard form.